of g of x be a composite function where f is the antiderivative of small f, okay? Therefore, the derivative of our antiderivative is my original function. Okay? The derivative of the, so big F, guys, is the antiderivative. So the derivative of your antiderivative is just your regular function. Yeah, that too. Yeah. Or the antiderivative of your derivative is your function. Okay, so if I want to differentiate this, what would it equal?
Regular F.
No, we're deriving it.
Yeah, it becomes lower.
Yeah, we'll get that out. Yes, you're right, but I'm going to get there. Okay, so f prime of, leave the inside, times g prime of x, the derivative of the inside, right? Chain rule. So what we're going to do is we're going to learn how to antiderive functions that were chain rule functions. So we kind of already did that a little bit where we derive by the derivative of the inside, but we can deal with more complicated functions. Okay, so rearranging this, we could actually rearrange this to be f prime of g of x times g prime of x.
We're doing all these pages today.
It's not that much. No, we're not doing volume. That's an optional lesson. Wait. Okay, it is. Yeah. Sorry, just moving into switching sides. You'll see. Okay. Just wait. Okay, I just want to prove. Okay, rearranging. Okay, sorry. Just whatever. We're integrating both sides. No? Oh, we forgot the dx. Sorry, dx, because we're integrating it. I get tired of explaining this. No, it's okay. Obviously it's not, it's really abstract, so that's why it's tough. It's the area, right? This is our f of x times d of x, gives us our rectangle, and we are summing. This is the sum of all those little rectangles, which gives us the area under the curve. So this is representing length times width, and that's that change of x is the width, and the height is our y, and that's our y here. Okay? Sorry, I should be a little bit more patient. I just feel like I've explained that a lot. I think I have. I think I said it like 5 times yesterday. Since integration is the inverse of a differentiation, right? So these are opposite of each other. We're integrating a derivative. Then this is going to become f of g, thank you, plus c. Ugh. Okay, so now we're gonna use, this is the substitution. So we're gonna let u equal g of x. So what this will look like then is f of, you're gonna love this, f of u times u prime. Oh, sorry. Yeah, that's okay. That's fine. Yeah, that's fine. Times d of x is going to equal to, yeah, f u plus c. Sorry. Yeah. Yeah, I made, yeah, sorry. I guess I should have chose a different letter, but they usually use U for substitution in calculus, and then V is your next letter they choose. So you can handle it. You're mature enough, right? Okay. All right, so collapsing the equation. So what we're going to do is we're just going to use substitution today. Oh, what happened here? We missed a bunch of stuff. That's okay. I'm going to skip the theory. It's online. Let's go to the next page. Okay. Okay, so basically what we're doing is, if we're dealing with a composite function, okay, what we're going to do, sorry, this should be f prime, yeah, dx. If we want to integrate it, we're going to use substitution. So we're going to actually let our g of x be equal to u. Okay, we're going to use substitution. We have a composite function. We're going to derive derivative of the inside, reduce to an easily integrated function, we hope. So let me show you what I mean. Because if we have a chain rule, somehow there is a derivative of the inside being multiplied, and we need to get rid of that. So our method is to recognize the proper form, define ux, let x be the inside function, substitute u of x and the d of x expression into the integral, integrate in terms of u, back substitute. So I'm going to actually, we're going to skip some of this stuff and just go straight to some examples so I can show you what I mean. No. No, that's a composite function. And then g prime of x, yeah. Yeah. So this is our composite function. And remember, it was our composite function always was multiplied by the derivative of the inside. Yeah, so let's go straight, ignore this.
Examples are the only thing that we do.
Let's go to some examples, okay? It's going to help, yeah. All of this words, I don't think it's going to help us. So what we're going to do is looking at this function, okay, it's really ugly. Could we actually expand this and make it simpler? No. I recognize that this is probably the chain rule. Why do I recognize this is probably the chain rule?
Because you got the derivative of the inside and
Yeah, you see the derivative of the inside on the outside, okay? So what we're going to do with this function is we're going to let this x cubed minus 2 be equal to u. Okay? So you guys okay? Is equal to x cubed minus 2. Okay? So we need to figure out, is du dx. So what would that equal be? 3x squared. Okay, so what we're going to do with this is now we're going to solve for dx. So what is dx equal to if I rearrange this for dx? Some of them, yes. What? du over 3x squared. So we want to change this function instead of in terms of x, we want in terms of u. So now we're going to sub in. So x cubed minus 2 is u. So u to the negative 3 times 3x squared times, what's dx equal to? du over 3x squared. And what should happen is the x's should all cancel out, so you just have a function in terms of u. Okay, so they do. This is lovely. And so now we're just integrating a much easier function, u to the negative 3 times du. Okay, much easier. What this has eliminated is the derivative of the inside from the chain rule. Okay, so if we integrate this, what are we going to do to our u? Add 1, so it becomes negative 2. So in front would be negative 1/2, and then plus c. And last, we're going to sub back in u. What's u equal to? We integrated, right? It's gone. Yeah, because this is length times width, which is giving us our area when we integrate, right? Length times width, which is equivalent to our area. The sum of our length times width is equal to the antiderivative of our area. Okay? U is x cubed minus 2 to the power of negative 2 plus c. Now you don't have to use substitution. Sometimes you can just figure it out by just dividing by the derivative of the inside, right? Kind of like today's quiz.
Sometimes you can just.
Yeah. But this is it's a method of substitution. Now you're going to have to use substitution when you deal with integrating things that were the product rule. Yeah, that's ugly, which you won't do until next year, if you choose to take calculus. Okay, so what's our u going to be in this case? What's our u going to be? What do we want to replace? X squared minus 5. So du dx is 2x, meaning that dx is equal to du over 2x. Okay, so we're going to sub. So instead of writing x squared minus 5 to the 4, we're going to write u to the 4 times 2x times, instead of writing dx, we're going to write du over 2x. And what happens? The x's will for sure, it might reduce. Okay. So now it's an easy function to integrate, which is just equal to 1 over 5 u to the 5 plus c, or x squared minus 5 to the 5 plus c.
There aren't application questions.
Yes, there are.
Yeah. That's the worst.
But we aren't going to necessarily cover them so much. No. There's an optional lesson which I have in your book on volume.
I don't anymore, so we shouldn't do it.
Okay. Okay, so this guy, you could also write as sine x squared cos x. So what could I set as my u here? Sine x. Okay, so now we find du dx. What's the derivative of sine? Cos. Rearranging that for dx gives me du over cos. Noises? Is that helping? Okay.
What an invention.
Thank you. You could also try and just adjust the monitor if you like. Okay.
That's absurd.
Okay, so u squared cos x. My screen, do you hear the noise? Here, let me try something. It's the heater. Okay, so guess what happens? Cancels out. So integrating this, what is it going to give you? That's not true. 1/3 u cubed plus c. So subbing in u, sine cubed x, make sure your cube is here. Yeah, or you can put your brackets. Sorry, I went too fast. Sorry. Oh, wait. Tell me when you're ready, Cody. I mean, Tyler. You guys are attached to the hip, right? All right. Do you want to try the next one on your own?
Well, suddenly when
Okay.
it's different.
It's not different. What would my u be?
None of them have a square. So your u?
3x squared. Your inside would be your u. Okay? Okay, so du dx becomes whatever's inside, yeah, of some, whether it be there's a power or 6x. Derivative of 3x squared. Okay.
That's what we're doing. And that becomes...
Yeah. du dx, right? Derivative of u with respect to x. Sometimes I make stuff up, but not this time. Yeah. No, I didn't make it. I wish so. I did that. No. Okay, so what would this look like? Yeah, it's great. Hey? Yeah. I should show that sometime. Maybe tomorrow. Okay, so cosecant. Cosecant u times cotan u times x times. Well, because we can't replace that. What's going to happen, though, because that was from the derivative of the inside, right? And that's why this is going to cancel. That's okay. That's okay. We can just move the 1/6 out front. So, in fact, you could even put the 1/6 in front of this. Yes, you can. Right? Yes. The integral of the constant times a function equals the constant times integral of a function. Why does d turn into 1? Okay.
So, how is this a chain rule?
Why? Okay, well, what was because the derivative of the inside.
Where is that?
Right, we have an inside function. It's a composite function. So, looking at your formula sheet, what's the antiderivative of cosecant cotan? It's negative cosecant. So this will be, so negative 1/6 cosecant u plus c. Looking at our formula sheets. Right, we look up cosecant cotan on the yellow sheet. It's yellow for antiderivatives. Okay, because of this 6 here, I just put it in front, the constant front. You could put the 1/6 here if you like. Either's fine. Yeah? It really is. It really is okay.
This was really easy until this question. I was like, oh, I don't need to do stuff.
And then you do. Okay. Do you want to try the next one on your own? All by your lonesomes? Okay.
So how is this? Where's the answer?
This was just a side note. Okay? Yeah. Oh. Yeah, we're good.
No, we shouldn't have a final exam.
No?
No. I'm good without a final. There's literally nothing obligating you to give us a final. We could even tell Mr. Pease that we have. Or give us all exactly what we have in the class. Yeah, he's thinking about it, you can tell.
Then
How about if we come to a consensus? I have an idea. How about our replacement exam mark? If it's over, like, or it's around class average?
I'll think about things. But so far, there's still a final. Okay. What? Okay. What would be your U here? You guys done? Did you finish this question? Yes. Okay, so just Ben. Anyone else? No? Yeah, I'm working.
Like, this one is so easy.
Mm-hmm.
The other one, the last one was different from all the other ones. I don't think the other ones are the same thing. The 6x can just cancel out. There it is. How is it? The next one's wrong. Is it? Yeah, it's wrong. Yeah, I don't know what to do with this on a 6.
Same idea.
I
hope I'm wrong.
Yes. Yes. Okay, so you know what to do there? Now we're going to, so we're replacing, we're subbing in for our dx, du over 6x, and we're subbing in our u when we see 3x squared plus 7. So we're going to rewrite this now as u to the 10 times 6x times, my dx is du over 6x, which crosses out. So we're integrating u to the 10 du, which you should get 1 over 11 u to the 11 plus c, and then last we sub back u. Oh. Okay.
So you don't actually have to sub in u.
I guess somebody who got a wrong.
You could figure this out on your own without substitution, yes.
No, like even if you just left that as 3x squared plus 7.
Don't start thinking.
And then you divide by the derivative of your inside. You have to remember to divide by the derivative of your inside, right?
Yeah. All the outside. You do. That makes sense in my.
Okay, you got it. You got it.
No, that means he doesn't get it.
Okay, so same idea here. My u is still going to be 3x squared plus 7. My du dx is the same, so dx is still du over 6x. Okay? Yes. Yeah. So the only difference here is when we have x times du over 6x, what happens? It becomes 1/6. So we're integrating 1/6 u to the 10. Now, if you want, you can put the 1/6 in front of the integral. It's the same idea. Doesn't matter. Okay? So when we integrate this, what's our power going to be? So we have 1/6, 11. Same thing. And then 1 over 11. So it actually becomes 1 over 66.
Oh, so it is wrong.
You make it right.
He's the kid who made a weird sound. Ben Schreiber? What? No, besides.
That was a weird sound, you're right.
Yeah?
That's the last time you made it.
How come the 1/6 applies to constant as well? The 1/6, like you know how to what's supposed to be not to this as well?
Yeah, it just always applies to this guy.
It always
Yeah.
applies, or just
Yeah, because you don't know what the constant. Right. Yeah. Okay, so turning on to the next page. Yeah, the next lesson. What? That's what we're doing right now. That's it was a part B. That's why I said it's 2 short lessons. So this is a part B of today's. Okay? I like this one. Get it? Philosophy.
I think we lost Larry. That one's not related to math.
No,
I
no.
understand the one.
But this one I like.
Hey, happy birthday, here's a sack of
Okay.
You should like that one.
I really like that one.
I like that one. I don't get that one.
Yeah, okay. All right, so the only difference, substitution rule for definite integrals is after we integrate it,
Find C.
we have to find, no, we don't have to find C because we're actually evaluating it between two, we're plugging in numbers. Now, there's 2 ways to do this. The first is we're still going to start with our u because we're using substitution. So what would my u be here? Jonas, what would the u be? 1 minus 4x cubed, right? That's inside the square root. That's inside another function almost. A function inside a function. Okay, guys? So then du dx would be negative 12x squared, making dx equal to du over negative 12x squared. Oh, today? Oh. Well, it's good to actually do something, eh? Okay, so we're evaluating this from -2 to 0. But we have 2x squared. The square root, what are we going to write it as instead?
U to the 1/2.
U to the 1/2. So that's going to be u to the 1/2. And then dx becomes du over -12x squared.
Oh, you're replacing dx with that.
Yeah.
Oh, he gets it.
Yay.
I still don't.
Okay. What constant can we pull in front? -1/6. Or you can just have,
I have a question.
yeah.
Why can't you leave the du?
Yeah.
What do you mean?
BU.
Yeah, what do you do with
Doesn't
the
have nothing else.
So,
derive it goes away? Why?
yeah, well, after you antiderive it, because as we talked about yesterday, this is a change of u, right? And so this is talking about, this is our length times our width. And the integral represents the sum of all the little rectangles, which is basically equivalent to the area underneath. And so what we're doing is we're writing the length times width is equivalent to the area, which is the antiderivative.
Yes, but we don't do anything with du.
Well, yeah, you're right, because we're making that approach like almost nothing. And so
the width of
Nothing.
that's our width of our little rectangle, right? The change of whatever. We're making them really tiny. We want to make infinite amount of rectangles. So this is almost, right? Nothing.
He doesn't know what his rectangles are, do you?
no.
From yesterday's lesson, yeah.
He doesn't.
You might want to look at that.
Well, I understand it. So the really skinny.
Yeah, and these are the change of x. It's like the width, and then this is our f of x. Yeah. Okay.
Like, these are all little lines and that's our area. I'm like, okay.
Yep. Okay, so antiderivative, we have -1/6 times something. Adding 1 is 3 over 2. And so this is 2 over 3. Now, do I have to write plus c in this case? What's wrong? Right, because we're dividing by 3 over 2. Yeah. We don't have to write plus c because we're evaluating it between two values. Now, this is between x equals -2 and x equals 0. Not for what u equals. Okay, you can't just sub these in here for u, right? This is from x equals -2 to x equals 0. So we have to put back the x. So this reduces to -1/9. U is 1 minus 4x cubed to 3 over 2. And now we can evaluate this between -2 and 0. Okay,
Because with
this?
no wait. Because you're times by du, does that whole side reduce?
No.
Or you just get rid of it?
It's gone, yeah. It's kind of like just a notation. This is your function, and that's what you're taking the antiderivative of. I mean, if you get down to the bare minimum, ignore this, take the antiderivative of this. That's what you're doing.
Yes, but I'm just
Yeah.
what is the point of that?
Okay, the point is to represent the area, length times width. That's the point. So it's a notation, really what it is. Okay? Okay, so larger minus smaller. So -1/9. 1 minus 4 times 0 cubed to the 3 over 2 minus, -1/9. 1 minus 4 times -2 cubed. Oh my gosh. To the 3 over 2.
All the if you go through your voice and like say in the lesson, every now and then there's just something funny and you make it so.
Oh. That would take a lot of work though. to go through all the hours of video. Okay, so 0 cubed is 0, 4 times 0 is 0, so we just have 1, so negative 1 ninth times 1 is negative 1 ninth, minus negative 2 cubed is negative 8. 1 minus negative 8. Oh, shoot. Negative 8 times 4 is 32, and it's negative 30. So it's 1 plus 32 is 33. And then you have 33 to the power of 3 over 2. Oh, it's so ugly. So it's negative 1 ninth to the 33 to the power of 3 over 2. So let's answer. Oh, it's so ugly. Well, what happens with our 1 ninth? Oh, no, that doesn't happen. Sorry. We can factor out the 1 ninth, though. What? So we have negative 1 ninth plus 1 ninth. And this would be the square root of 33 cubed. As an exact value. It's ugly.
Yep.
She's ugly. Okay, now there's another way. Do you guys do all this work in the first box? Yeah, you probably do. Okay, the other option is when we are at this point, before substitution, when we had negative 1 ninth, u to the, guys, 1/2 to u. Now this is from x equals 0, right? To x equals negative, no, sorry, x equals negative 2 to 0. To x equals 0. What you can do instead, if you want to work with this function, was this what it was equal to? Sorry. That was actually our antiderivative. The other option is you can change your values here. Okay? So instead of subbing in for x, you can find the values of u. Since we know u is equal to 1 minus 4x cubed. Okay? So if you know u is equal to 1 minus 4x cubed, guys, I'm sorry, we're almost done. This is our last lesson, so hang in. Okay? I need to get this finished in 15 minutes, folks. So let's go. Okay? What we can do is figure out, okay, at x equals 0, what is u? So u would be 1 minus 4 times 0 cubed, or 1. At x equals negative 2, what's u equal to? We figured this out already. It was 33. So instead, yeah, we can evaluate this from, there's no du here anymore, sorry. We can evaluate from x, so negative 2 became x equals 33 to x equals 1. Or u equals. Ugh. This day is going not very well.
It's okay.
Okay. Okay, so then you can actually change your values for, instead of in terms of x, they can and then you just have to sub that beautiful thing in. It's a lot prettier. Okay, so remember, it's a to b, so b minus a. So be careful because now it's not always a larger number minus a smaller number. Right? So you have to be careful. Yeah, because it's b to, so this is a to b, so the 1. So it's the top minus the bottom. Okay, 1 to the 3 over 2 minus what? Negative 1 ninth, 33 to the 3 over 2. and 33 to the 3 over 2. That's not very nice. Okay, one more question, and this is our last question ever. Really slow. Okay, so let's try this one really slow. No, we're going to go slow. Okay, don't be done. Okay, looking at this, we want to first define, okay, it's a composite function because we see a function inside of a function, right? X squared inside of cos. So what would be my u value, Wiley? Miles? X squared. U equals x squared. Then what's my next step? Guys, stay with us for this last question. So next step is, Greg? Next step. du dx. Which equals 2x. After we have that, what do we do next? dx is du over 2x. Okay, so now that we did all the pre-work, we are ready to do what? The subbing in. Okay, so this is x equals pi over 0 to x equals pi over 2. Now we sub. So what can we sub in this place? U. So x cos of u times du over 2x. What? Yeah, but you wouldn't. Okay, but you could though. You could. You absolutely could. Okay, so our x's cancel out. Yay. Now we have a beautiful function. What's in front?
The big thing.
Okay, x equals 0. I'm going to write that. X equals pi over 2 so we don't confuse it. And what constant do we have in front? 1/2 because of the 2 here. Comes 1/2. Right? Cos u du. All right, we are ready to integrate this function. It's a lot prettier. So integrating it, we grab our yellow sheets, we look up the integral for cos, and I'm pretty sure it's sine. Well, you're doing opposite, right? So you can look at the green sheet as long as you go opposite. So cos is sine. So that's derivatives. You just have to go backwards. Okay, so you have 1/2. Just the constant stays in front. Sine u. We don't need plus c because it's a definite integral. From x equals 0 to x equals pi over 2. Now, we have two options. At this point, we could either sub in our u and then evaluate from x equals 0 to pi over 2, or we can change these in terms of u. No. Okay, let's do the first. Well, there's some groans. Okay, so what we're going to do is rewrite this as 1/2 sine of what? X squared. And then we're evaluating this from x equals 0 to x equals pi over 2. Okay, so the nice thing about leaving it in terms of x is you're not going to confuse who's larger and smaller, right? But it's always the top minus the bottom is another way to look at it. Because it's a to b, right? In the notation, this is a and this is b, which is equivalent to f of b minus f of a of our function. Okay? That's big F. So what is 1/2? So we have 1/2 sine. Which one is going to be squared first? Pi over 2. Oh, this is ugly. Squared. This is not going to be an exact value necessarily.
Why would you do this?
Sorry. 1/2 sine of 0 squared. What is sine of 0? No, they're not. They're right. 0. So guess what happens to this whole puppy? Gone. So our final answer is 1/2 sine. You could write it as pi squared over 4 if you like. Or you can actually put that in your calculator, get your decimal. All right? We have conquered. We've succeeded. You have survived. Seriously, congratulations for making it this far. It's not an easy course, and you're here. That is something to be proud of, especially because you guys are doing 30-1 at the same time. So, your homework is there. Come on, I have to go to Costco. Like,
Right now.
go. I don't have any.